Okay, will do. First, I want to say thank you for having me on. I've been a Xamarin University subscriber for 4 years now, I think. So it's kind of really cool to be on the other side of the microphone for the first time. So hey everyone, I'm Jim Bennett. I'm a senior cloud developer advocate at Microsoft. For those of you who haven't heard of these cloud developer advocate things, my job is basically to help developers build cool stuff with Xamarin, either doing things like the Xamarin University lecture, creating samples for you, creating videos, helping you write code, or taking any problems you have back to the engineering teams. And I just want to start by saying you can ping me at any time with any questions around this or anything to do with Xamarin, any problems you've got, anything you've done that's cool. You can ping me at Jim.Bennett on Twitter or jim.bennett@microsoft.com. So introduction's over. We're here to talk about two of my favorite things, Xamarin and F#. Now, I will just add, if there's any F# experts on listening right now, I'm not an F# expert. I'm an enthusiastic amateur. So if you look at my code and go, what is this guy doing? Sorry, I can write okay-ish F# code. So apologies for any experts who think my code is a little bit poor. So what are we going to talk about in this lecture? We're going to start by doing a quick look at what F# is for those people who haven't really done any. This isn't going to be a tutorial on F#. So if you want to learn how to actually code in F#, how the language works, we're not going to cover that today. Instead, I highly recommend checking out the self-guided learning courses from Xamarin University on F#. So I actually tried to learn F# a number of years ago and just couldn't get my head around it. And then I saw that Xamarin had these F# lectures. I worked through those and it clicked in my mind. I kind of understood what it was, and that's what really started me off on my journey in F#. So if you want to learn the language in more depth, I highly recommend checking out the Xamarin University self-guided learning on F#. So as I said, we're going to start with a quick look at what F# is. Then we're going to look at how you can build a Xamarin app using F# in its kind of most dumb form as a drop-in replacement for C#. And then the bulk of this, we're actually going to look at how you can build Xamarin.Forms apps in a functional programming style with this thing called Elmish. So let's just dive right in.
Hey, Jim.
Yes.
Let me jump in real quick. We're still seeing the title slide. Should we be seeing that, or did you move on?
Yep. Still seeing the title slide.
Excellent. Okay, great.
Yeah. And now you should be seeing the next slide. Yay. So what is F#? What is F#? F# is a mature, open source, cross-platform, functional first programming language. That's the official description from the F# Foundation. So what does that mean? Well, F#, as you can probably guess by the sharp in the name, it is a .NET language. It is something that runs inside the .NET runtimes. It spits out IL, it interacts with the .NET Framework, .NET Core, and other .NET platforms. It is mature. So it's actually been around since 2005 in its stable form. The very first stable release was 2005. It came out of Microsoft Research. The language was invented by a guy called Don Syme, who's kind of like the benevolent dictator for life of the F# platform. It's a fully open source language. So you think now we're seeing C# as open source. We're seeing the Roslyn compiler as open source. We're seeing discussions around the language happening on GitHub. F# has been like that since day one. It's fully open source. There is an F# Foundation, which is like a not-for-profit that manages the whole F# process. This is basically an elected body who have oversight on the development of the language, where it goes, the tooling, etc. around that. It's cross-platform, so you can run F# on Mac, Windows, Linux, and as we're going to see today, iOS and Android. And it is a functional first programming language. And this is something I just want to take a little bit of time to talk about. You may have heard of functional programming, and there's languages like Haskell, which are functional programming languages. And these are languages where you build functions, you use immutable data, and the whole idea of object orientation just does not exist. They're pure functions. F# is not quite like that. F# is a functional first programming language, which means out the box, idiomatic F# is functional programming. It's functions, it's immutable data, it's all the things you expect from functional programming. However, you can also do object-oriented programming in F#. And this is actually very important because F# is a .NET programming language. If you think about the .NET framework, everything derives from system.object. You have on iOS, you have UI view controllers. On Android, you have activities. On WPF, you have pages. All these things are classes. You think about the system namespace, it's packed full of classes. And to be able to interact with these objects, these different classes, you have to support object-oriented programming. So F# is a functional programming language that also supports object-oriented development. And that's actually really helpful for us when we're trying to build things like Xamarin apps. Now, I have said it's open source. It is guided by the F# Foundation. You can get in there, you can submit requests for code. One thing Microsoft does retain, though, is control over the language, simply because it has to be able to interact with the .NET framework. If we bring new things into .NET, we want to do things like .NET Standard, we need to make sure that F# supports that. So although it is open source, the primary development work and the main oversight does come from Microsoft, simply because we have to keep it consistent with the .NET framework. Now, I will also add about F# is it's not scary. It's very easy to see academics talking about lambda calculus and monads and joking about how monads are just monoids in the category of endofunctors and all these long, scary expressions around functional programming. Really, it's not that scary. It's a different way of thinking to object-oriented programming. If you're a C# developer, the move to F# involves a little bit of a mental leap, but it's not hard. But unfortunately, it's surrounded by lots of complicated terms. But don't be scared. You don't need to worry about those complicated terms. F# as a language is actually quite easy to use, mainly because you write so little code compared to object-oriented languages. So it's quite easy to read. So don't be scared. If you dive into F#, don't be scared by the long words. And I'll also add as well that F# is everywhere. So it's a .NET language. Anywhere you run C#, you can run F#. Visual Studio for Windows, for Mac, supports F#. Visual Studio Code supports F#. Anything doing C#, you can do in F#. You can build WPF apps in F#, console apps in F#, Xamarin apps in F#. You can do all these things using F# as like a drop-in replacement for C#. And then there's tools like, for example, Fable, which is a web application framework where you can build apps in F# that is in a more of a functional style programming language. So that's a kind of high-level overview of F#. So, Rob, I don't know if there's any questions that have come through on that yet.
Just one.
Yep.
Why would we want to build a Xamarin app in F#? And also a second one, can we do UWP in F#?
So why do you want to build a Xamarin app in F#? Because F# is an awesome language. And as we dive more into the different framework, into the Elmish framework, you'll kind of see what some of the upsides of using F# are. So I'll kind of hold that question off until the end, because I'm pretty sure it's going to be answered as we carry on going through. And UWP, yes, should be able to. At the moment, Elmish, what we're going to look at is just iOS and Android, but we can expand that to be UWP as well. So yes. Okay, right. So let's dig in. Let's do F# and Xamarin. And so what I'm going to do is I'm actually going to just show off a Xamarin app built in F#. Now, from Visual Studio for Mac, I can actually go File, I can go New Solution, and under Multi-Platform App, we have Blank Forms app, and I can choose C# or F#. And this is the same across the whole of Visual Studio. iOS app, C#, F#. Android app, C#, F#. .NET Core, C#, F#, whatever. So F# is fully supported in Visual Studio for Mac as just a different language choice when you choose different projects. On Windows, there's a whole separate Visual F# section. So normally you have Visual C# and you have your project types. There's a Visual F# section in the other languages area, which you can then use to choose an F# project. Now, we don't have complete parity at the moment between the templates on Windows and Mac. So we don't have the file new Xamarin.Forms app in F# on Windows, but we are working to align that up. We are working to make that better. Now, I've got here an app I just built very quickly, the kind of canonical Xamarin.Forms app of a button I click that increments a counter. And this is all built in F#. So just like a C# app, I have my three projects. I've got my iOS app, my Android app, and we've got a class library, which is a .NET Standard 2.0 class library. In iOS, I've got my assets, I've got my launch storyboard, I've got my info plist, the same as you get in a normal iOS app, and I have my app delegate. Instead of a .cs file, it's a .fs because it's F#, And in here, I've got my app delegate. I derive from the forms application delegate. I override finish launching. Now, this you probably can read this if you're used to Xamarin.Forms, you're used to C#. This should be fairly readable. And this is just literally using F# as a drop-in replacement, using F# as an object-oriented language. But one thing you will notice about F# is I'm not declaring many types. So I'm not saying that finish launching takes a UI application and returns an NS dictionary returns a Boolean. Instead, the compiler is working this out for me. So F# has this thing called type inference, which allows the compiler to work out what your types are. So it knows that this returns a bool because the last statement in my function returns a Boolean value. So I don't need to say that my function returns a bool. So that's just one of the little cool things about F#. Now, if I then flip to my Droid application, it's exactly the same. I've got main activity, again, inherits forms at compat activity, overrides on create. So exactly the same as used in C#, just using F# as a drop-in language. And then finally, I have a page. It's XAML. I've got bindings. It's all same. I've got a XAML.fs, derived from content page, load some XAML, set a binding context. I have a view model. This view model has got properties, it's got a command on it. It's got pretty much everything you'd expect in C#, just written using F#. So this is the kind of out-of-the-box, I can drop in F# instead of C# way of building apps. And if you can see my simulator when it finally spins up, you'll see that I have the same kind of experience. I click increment, I can stick breakpoints on here, I can click increment and hit my breakpoint. Yeah, exactly the same as if I was doing in C#. Now, if there's any F# people watching this right now, you're probably grimacing at this kind of code. And one word in here is particularly nasty to F# people. It's this word mutable. Now, F# as a functional programming language doesn't like mutability. Functional programming likes immutability. It likes functions. It likes to have a function that takes some data in, spits some data out. It doesn't like mutable state that can be changed all over the application because it's very hard to track that state. It's very hard to deal with that when you have multiple threads hitting a system really hard. It's just not the way that functional programmers like to do things. If you can just kind of think of the kind of problem you might get with C#, imagine the number of times you've built a view model and you've had to initialize multiple things inside the view model to get the state of that view model to a point at which you can write a unit test against that view model. Yeah, you have to initialize a load of mocks coming in and set a whole lot of values just to execute a command to unit test what happens. That's the kind of thing that functional programmers just don't do because everything is a simple function, data comes in, data comes out. This code here doesn't really follow that kind of idea of a function with data in, data out. So how do we write Xamarin apps using functional programming? That's the kind of question that is starting to be asked by people. We can do this, we can use F# as a drop-in language, but it's not the ideal way. So how can we do it in a different way? And one of the things that kind of makes it hard to build any kind of UI application in functional programming is the fact that UIs are objects. So the reason we had our main page, the reason we had our view model and our properties in our code is because the UI is objects. It expects objects. UI components have properties, methods, and events. They are objects. So how do we align objects with the functional programming style of writing functions that just take inputs and give out outputs? And that's a problem that people have been trying to solve for a while. How do we do this move from objects in the UI to functions? And there's a great solution to this problem that came out of the JavaScript community. So with JavaScript, you can write functional programming if you want to, but with HTML, your DOM is objects. So how do you tie up functional JavaScript with HTML? And they came up with this idea, which is called Elm. And Elm uses the design pattern model view update. Now, I'm sure you've all come across design patterns before. MVVM, model view view model, is like the canonical pattern for Xamarin.Forms apps. MVC for iOS, MVP for Android, or MVVM for both those frameworks with things like Cross. Elm uses model view update. But the way it does this is slightly different to what C# developers think when we think of things like model, view, view model. With model, view, view model, the model is an object. It is a class. It has properties. It has methods. The view model is a class. It has properties. It has methods. And the view is a class. It has properties. It has methods. Whereas with this Elmish architecture, with Elm architecture, the model is a record, a immutable container full of data. The update is not an update class. It is a function. The view is not a view class. It is a function. And the way that the Elm architecture works is you have an instance of your model, and this is the state of your system. And then when you do something, like you click on a button in the UI, a message is passed to the update function. The update function takes the current model, spits out a brand new variant of the model. So it's not the same model, it is a copy, completely separate, brand new copy with values changed based off the message that's been received. That model then gets pumped to a view function. This view function takes the model and spits out a virtual UI, sometimes called a shadow DOM in the web world. So it is a virtual representation of the user interface. And then behind the scenes, that virtual representation is then used to construct the UI. So actually, let's look at this in terms of a real example. Let's look at this if we were building an Elm app to do the same click a button to increment a count type idea. So when we launch our app, our UI shows that our count is 0. And we have a model, which is our initial state of the system, which has a field on it called count, which is set to 0. We then tap the increment button. That passes an increment message and the model to an update function. This update function creates a brand new model with the count set to 1. That brand new model is then pumped into the view function, which spits out a virtual user interface. And this virtual UI essentially maps one-to-one with the real UI, except in the output, our label now says count is 1. And then behind the scenes, the Elm framework looks at those differences, sees that the UI and the virtual UI are identical except for the text of the label, and then updates the actual UI to match the virtual UI. So model comes in with a message to an update function, spits out a brand new model, goes into a view function, which then updates a virtual UI, which causes the UI to update. Now, you're probably thinking, why? Why would I want to do this? Well, the model is immutable. So, and your update function is always called by the Elm framework synchronously. So that means things like threading issues just don't happen. So imagine, if you will, you have a view model, and that view model's got a count on it. And then you have a button. When you click the button, it will read the count from the view model, increment the count in the view model, write that back down to the view model. So the kind of the C# way with the view model, you have a button, reads a value, increments it, writes it down. At the same time, if you had a timer that also increments that, you could hit a race condition. You can have a point where timer reads the value of 0, button reads the value of 0, timer increments it to 1, button increments it to 1, timer writes down 1, button writes down 1. Really, the combination of the timer and the button, your count should go up by 2, but because of a race condition, it only gets set to 1. You just don't have that problem with Elm. Because the update is always called synchronously, and your model can never change, when you click the button, it passes the message and the model to update, it gets incremented. Timer fires, message and model goes to update, it gets incremented. So a lot of threading problems go away. A lot of the things you may have to do in view models to try and synchronize updates goes away. Your model also is the single source of truth for the entire app. So I don't know how many times you've had to do this, but I've seen Xamarin apps with view models and repositories and services with data in it, and trying to understand where the one source of truth for the state of the system becomes very hard. You've got all these different layers where the code could be. In this particular model, you don't have that because the model is the single source of truth. It can only be updated by the update function. You know that's the only place it can be changed. That model is your single source of truth. And then by having a virtual UI, instead of actually spitting out real UI objects, spit out virtual UI, you can unit test everything. You can write a unit test against your update function. if I have a model X and message Y, update should spit out model Z. You can unit test that. If I have model X, my view function should spit out virtual UI Y. You can unit test that. So you can unit test absolutely everything. Not UI tests, we have to spin up an actual web in the case of Elm, but it's unit tests. And as well, if your view function is particularly heavy in terms of load, you could run that off the UI thread because you're not interacting with the UI, you're just creating a virtual UI. So it's kind of quite a compelling framework. And it's quite nice. You're writing these nice little functions, you can unit test your update, your view, no worries about threading issues, everything's all immutable, everything can be unit tested. It's pretty fantastic.
So Jim, we got a couple questions here, real quick.
Yes.
That I jumped in. So you're talking about testing, and if you're using Elmish and you're using F#, can you do the UI test in F# with the REPL and everything like that? Is there any difference between just using C#?
No, you can create UI test projects in F# if you want to.
Cool.
So if you're using like Xamarin UI test, you can do that in F#.
All right, and then another question is, what's the memory usage impact of creating a new model for every update? If you're allocating all these different objects every time, nothing's mutable. Does this use more memory than a typical MVVM Xamarin.Forms app that you'd create in C#?
Usually no, because when you're doing view models, you're creating quite a lot of different view models all over the place. This is just one model, so it's kind of one state, and the update doesn't happen that often. Usually the update happens when you kind of interact with the UI. So yes, when you click a button, a new model gets created, but these models are quite small in terms of size. So you're not going to be building up a massive history of models. You're going to allocate one new object and then garbage collect it. So no, it's not going to have any noticeable impact on memory size.
Great, thanks.
Cool. Okay, so that's Elm. Obviously, this was designed for web. And in the F# community, they wanted to take the same ideas and apply it to web for F#. And they came up with this thing called Elmish, as in it's a bit like Elm. And then Don Syme, the benevolent dictator for life of F#, he decided to port Elmish to Xamarin.Forms. Now, this is something that's really quite cool. So the first thing to note about this is the reason Don Syme did this is not because he thought it would be a fun project to play with in the evenings. Don has actually been seconded onto the Xamarin team. So his day job is to make Xamarin and F# a much nicer experience. It's to help make sure the tooling is top-notch, but also to build out a framework. So Elmish for Xamarin.Forms is Don Syme's day job. So this is something that is happening. This is something we are building as the way to build Xamarin apps in F#. So it's getting a lot of love, a lot of support. And when Don built Elmish, he had a really smart idea, because he realized that we have Xamarin.Forms developers who know C# and know Xamarin.Forms who might be interested in moving to F#. We also have F# developers who are interested in moving to mobile. So rather than create one way of doing things and that's it, he actually came up with two variants, half Elmish and full Elmish. Now, I can never say full Elmish without thinking of Tropic Thunder, but it's not, you don't go full Elmish, you can go full Elmish. So what is half Elmish? What is full Elmish? So half Elmish, this is a way for Xamarin.Forms developers to start with F#. Your model, your messages, your update function, you define those in F#. But your views are defined using XAML with data binding. So this is what you're used to. This is the kind of XAML you would build every single day as a Xamarin.Forms developer, still using data binding. And then your view function, instead of returning a virtual UI, it returns the values of your data binds. So it actually returns the values of the binding. And then when your update function is run, the new model comes out, that causes the bindings to update, which updates the UI. So you still have XAML, you can still put the UIs in XAML the way you want, but you write the rest of your code using the Elmish model. And then we go full Elmish. Full Elmish has the virtual UI. So your messages, your update, your model are all in F#, and your view is defined in F# using a virtual UI. And the view function returns this virtual UI. The Elmish framework looks for differences, updates the UI. So this is more like the Elm we had for web. So best thing I can do is let's just dive in and write some code. Let's actually build something with this. So, zip over. Let's start with half Elmish. I've got myself a little project here, which is essentially a file new Xamarin.Forms app. Nothing particularly exciting. I've got a main page.xaml. If it's going to load, there we go. The standard hello Xamarin.Forms that you get when you do file new. So let's just add a couple of controls on here instead. Let's change this label and let's drop in a button. So I've got a label. The text is bound to message in an array indexer. I'll come back to that later. And then have a button where the command is bound to increment, an array indexer. This is the XAML I use for my half Elmish. So it's the same as the XAML you're used to. I then go to my main page, the actual .fs file behind it. And in here, I'm actually going to start building up the Elmish pieces. So I'm going to start by creating a module. I'm going to call this main page. For those who are not used to F#, you can kind of think of a module as being like a static class. Static class, static members on there. But in functional programming, it's just a module, just a way of holding stuff. And here I need to define my model. So I say type model equals count int. So I've got a model. This model has one field on it called count. Now this type is what's called a record type. So in F#, a record type is an immutable data structure. You can think of it like a struct in C#. When you create it, you have to set the fields and they can never change. The next thing we'll do is create my message. And this, I want a message called increment. Now, this particular syntax is to declare a thing called a discriminated union. Now, you can think of a discriminated union as an enum on steroids. So you can do things you can do in enum. You can say this is increment or decrement, just like an enum. Or I could say we can have a jump of int. So this value can either be increment, decrement, or jump with a number. Jump of 10, jump of 20, jump of 30. And I can add all manner of different things in here, foo of model, whatever. It's almost, if you're a VB programmer from the original VB6 days, you can kind of think of this a bit like the variant type, but cross between that and an enum. It can be one of these values, and these values can be typed. So it's kind of a very, very powerful construct. It's the kind of thing that if you want to do in C#, you're writing pages of code, and here you do it online. So that's the message. The next thing I need to do is create an init method, because when the app starts up, I need to create my model. So I'm just going to create a new model with count equals 0. Again, you'll notice I haven't specified the type here. The type inference has picked up that it's a thing with count. The only thing this could possibly be is the model. So it's already worked out as the model. And this init is called when my application starts up to give me the initial state of my application. In here, I'm just creating a new model, but if I wanted to persist my model to SQLite database, to a network share, web call, what have you, I could do that in here. I could load up from the SQLite database or from a file or what have you in my init method. Next thing is update. An update takes a message and a model. And in here, I'm going to do a bit of pattern matching. Match my message with increment. And if I get the increment message, I return a copy of the model. So this will take my model and copy all the fields over to a new one. But this will be a model with count equals model.count plus 1. So this will return a brand new model with my count being incremented. Now, one thing I will just point out here, one thing that's cool about discriminated unions and this match statement is if I were to add another type here, I'll get a little squiggly to tell me that I haven't matched my entire pattern. This is a nice feature of F#. The compiler stops you making mistakes. So if I built an app like this in C# where I was sending messages around, if I added a new message, there'll be nothing to tell me that I haven't handled it everywhere. By matching on it, if I actually add a new message type, the compiler will give me a warning if I don't handle it. So kind of another cool thing about F# is that the compiler helps you a lot. So that's the update. Finally, I'm going to add my view function. I'm just going to copy and paste this from over here because You don't need to watch me type. And then what this view function does is, what's happened to my indenting? So this view function, oh, there we go. All right, sorry, losing control of my keyboard here. There we go. So this view function returns a tuple. A tuple containing a page and then some bindings. Just add an open statement here, which is the same as the C# using directive. So it returns my page and then returns binding. It says message. The message should be bound. It's a one-way binding to a function that returns clicked equals and my model count. And then the increment is bound to a message of increment. So what this means is, to get the value here of the message, it will execute this function. So create a string of clicked equals count, get this value back, and use that as the value for this binding. This command, increment, when you tap the button, the command will send this increment message to the update function. So I can now just go and actually wire up the last little bit, which is to tell the app to use Elmish for everything. So I just drop this in here with a bit of a couple of using statements, and this says to what this does is creates a new Elmish program. This is my init function that creates my model. This is my update function that updates my model with a message. This is my view function, creates my view. We're dumping out the console, we're running this, and then this is creating our page that we run. So let's just give that a spin. While that's compiling, just have a quick review of what we've done. It's got a model here with a count. I've got a message called increment. My init function creates the model with a count of 0. My update function takes the message and the model, handles the message of increment to spit out a brand new model with the count incremented. And then my view function spits out my page, spits out my message as a binding and my increment as a binding. So that's now being very, very slow to build. Here we go. And then let's just pin this output so we can see what's going on. Okay, so you can see from the output here, the initial model has count equals 0. And as I click, you see the message, the updated model. So I can stick a breakpoint here, do that. Here's my message, increment. Here's my model, count equals 2. Do that again. Here's my message, increment, model count equals 3. That increments at default. We show 4. It's all very cool. Now, two things to note here. One is this view function returns these bindings. I can write unit tests against this. Because it's returning a page, I still have to faff around with the Xamarin.Forms in it, which gets a bit of a pain, but essentially I can unit test these bindings here. The other thing that's very cool is you'll notice in my application output, I've got my initial model, my message, and my updated model. Now this model is the state of the system at that time. So if my model contains the entire state of the system, I can always go back to any point in time in my app. With Fable, which is Elmish for the web, they actually have a thing called time travel debugging. And we could do the same here. We could do time travel debugging. I could add a little tool with a slider that as I slide back and forward, it updates the model to match these different points in time. So I can always see what the state of the system is. You could imagine, if you will, every time update gets called, you could then take the state of the system and send it up to App Center events. That way you could always see where somebody is. If you have a customer saying, I'm using your app and it doesn't work, if you could get the state of their model and the message they're trying to raise, you can actually then recreate their exact scenario. Something that's very hard to do if you've got data stored around in various different view models. So it's a really nice way of seeing everything that's happening. Because the state is this one immutable model that can't change, you can always see what's going on. So that's half Elmish. We're still using XAML, but we've got functions for handling our model, handling our update, and handling our bindings. So Rob, any questions on that so far?
No, not yet.
No? Cool. Okay, so that's half Elmish. Yeah, that's a bit of fun. Let's now go full Elmish. So if I flip over, I've got another app here. This is full Elmish. In this one, again, it's a standard kind of file new. Sorry, I forgot to say with the last one. I'll say it for this one. Elmish comes from a NuGet package. So in this one and the last one, I installed the Elmish.XamarinForms NuGet package. And this one, I've got an app where I've just got a brand new content page. So it doesn't do much. So let's recreate exactly the same app that we had before, but let's do it in full Elmish. So I'm going here. I'm going to create my module. It's called app. And then I'm going to do exactly the same that I did before. I set my type. Let me copy and paste this because you don't need to watch me type. So again, I have my model, I have my message. Now, my init method with full Elmish is slightly different. With this one, I actually return a tuple. So I've got my model, count equals 0, and then I return a command. Let me just drop in a couple of open statements in here. So with the full Elmish, I have this ability to return a command with my model. And a command can be used to do asynchronous things. So at the moment, I'm saying command of none. So here's the model, that's it. But I could also return a command of async message to actually allow the app to spin off something in the background, do something, and then pump a message into my update function later on. Or a command of subscription, so I could subscribe to something like a timer, so that kicks off the timer and I can then subscribe to the updates from there. One example use case of this would be if I had an app that needed to go and load data from a SQLite database or a connection to a web app, I could return an initial model with no data in it and a flag to say it's loading, so the view could then render a loading screen and return a command of async message to make the web call or make the database call to load the data, and then when that comes back, I can populate my model fully. So it's just a way better kick off things in the background if you want to. Again, I need my update function. Update takes a message and a model, and match message with. My IntelliSense is going over the top here. Increment, and again we can return the same thing. We can return the model with a count set and a command. Finally, let's build our view function. And this time we take a model and a thing called a dispatch, which is what we can use to dispatch messages to the system. And so here we can return our virtual UI. So this is where we actually start building our virtual UI rather than relying on XAML. So I can turn a XAML.content page, and this is a representation of an actual content page. So this isn't a content page. This isn't a Xamarin.Forms.content page. This is a virtual content page. So on here I can set properties such as padding. I'm going to set this to 20, and then my content page has content. So I'll set my content, and that can be a XAML.stack layout. And then inside my stack layout, I'm going to set maybe my horizontal options to be, let me just copy and paste some code because I'm lazy. I'm going to fix up the white space. So my stack layout, I've got my horizontal options, vertical options, I've got my children. In my children, I have a label. My label, the text is set to count the value for the model, and my button has a command. This command uses the dispatch that came with the view function to dispatch the increment message. So this is a virtual UI that is essentially the same as the XAML UI that we had in the half Elmish version.
So,
but of course,
so
yeah,
Jim,
sorry, Rob.
So in this case, you wouldn't have XAML?
No XAML here at all. This is all done through this virtual UI. Yeah. Just a side note, we're probably going to change the name of the XAML object here because there's no XAML. And obviously it leads to confusion because it says XAML, but there's no XAML. So this will probably get renamed fairly soon to something like View, but we haven't actually changed the name yet. So that's the view function. And then to actually use it, I just, again, same as we did in the half Elmish, I create my program with an init, update and view, and then run it with a console trace. So let's just kick that off. While it's kicking off, I'll just kind of review this code again. We have our model with count, we have our increment message, our init method, our init function returns our count and a command set to none, so that we're not actually doing it in the background here, but we could if we wanted to. Our update takes the increment message, returns a copy of the model with the model incremented, with the count incremented, and the command of none. And then we have our view function, which spits out a virtual content page with a holder property set. And that content is a virtual stack layout, which contains a virtual label, which contains the text set to the count. And while that's spinning up, flip back to the application output. And then you'll see, just like with the half Elmish in our application output, we will be dumping out the state of the model and the messages every time. So initial model count is 0, and then there was increment count as 1. So what's happening is, let's stick up the breakpoints on here, do the same thing. Update's the same. We have the message, we have the old version of the model, returns a new version of the model. So when we come to hit our view, our model's now been incremented to 7, and then it returns this virtual UI. And then behind the scenes, the Elmish framework will then rebuild the UI from this. And I can kind of take it from here, and I can build much more advanced UIs with the same kind of code. So for example, if I wanted to put, in fact, you know what, let's just drop in a whole load of code here. If I want to have a welcome screen, I could have a show welcome screen in my model. I could have a message to hide the welcome screen, and then when I initialize, I set the show welcome screen to be true, and then depending on the messages come in, I can remove the welcome screen first. And then inside my view, I can return a navigation page. And in my navigation page, I can return multiple pages. So I can say, always return my main content page, but based off the value of a property, return another page as well. So this would then show one page and navigate to the next. So I can kind of build quite detailed navigation-based UIs, all using this virtual UI. So if you think this app here essentially has 2 pages, one of which has a button that when I click hides the first page, and then has the standard click the increment to increase a counter, and I've written the whole thing in 76 lines of code, 76 unit testable lines of code. And yeah, if I wanted to play programmer's golf, I could make it even shorter. So just to show this one in action.
While that's
sorry, Rob.
Good question. Do you think we're ever going to be able to use XAML or with the full Elmish, or are we 100% preventing the use of XAML here?
We are talking about whether to allow inline XAML for some of these things. If you want to, why would you kind of mix and match? Because if you want to use XAML, then that XAML actually gets rendered down to a real UI. So you don't get the upside of the virtual UI if you have a real UI. You can't kind of unit test the real UI so easily. But maybe we could take the XAML and actually parse that out to the virtual UI. So it's still very much in discussion, that one. I don't know what the answer is going to be there. But hey, you know, this is an open source project, so we welcome people raising that as issues on GitHub and getting involved in the conversation.
And then we got one other question as well.
Yeah.
Are there any gotchas when you're interacting with object-oriented libraries from Elmish, like dealing with device capabilities, camera, AV foundation, anything that's object-oriented when you're calling it from F#?
Nope. So obviously F# as a language can quite happily talk to objects. So it's, I guess the things that the closest you get to gotchas would be things around callbacks. So if you're waiting for a callback from I don't know, a network, for example, if you're using the essentials to actually monitor for when there's a change to the network, then what you can do is when you actually construct your application, you can create subscriptions here to different events. So you could actually say subscribe to the event from the network, from the connectivity part of the Essentials plugin, and then every time a network change event is raised, dispatch a message. So everything revolves around dispatching messages. So yes, you could have Essentials dispatch a message that comes into the update and then turn something on. You know, like if you had an indicator on the top of the screen to say you're not connected. When you get the message coming through to say connectivity is being restored, you can update the UI to hide that. So you just, as long as you kind of think in terms of everything's got to pump messages through the system, then no, you don't have any problems interacting with other parts. Cool. Any other questions?
No, those are the only 2 for right now.
No. Okay, cool. So yeah, so here's like a 2-page version. This is now that it's run. So if I tap this go button, it navigates back. So just by stop this so we get full screen here. So when I tapped go, it changed this Boolean value of my model, which meant when my pages were created, the navigation page, we had the main page. This got set to false, so we never added this page to the virtual UI. So the virtual UI isn't just a page; it's literally the whole stack of your application. Now, obviously, this is like a large number of lines of code, but you then just spin this out to another function for each different page. You kind of make it more and more advanced if you wanted to. So it's a nice way of doing it. You can unit test all these functions. You can really create these nice models. And then obviously with apps where you have things like connectivity, where you have messages coming from servers, you have calls to the back end, because everything gets synchronized through this update function. There are no race conditions. It just can't happen. Every time a call from the back end comes back with something, it raises a message and it comes to update, no race conditions. In fact, what I'll do is I'll just quickly spin up another app that I've been working on that's a bit more advanced. I've been trying to build an app to track my daughter's pocket money. So I've got a 5-year-old. We give her pocket money every week, but we don't deal with cash. You know, we're part of this cashless society. We don't do cash. So I can't keep putting coins in a piggy bank for her. So I've been building an app to try and help track the money that she's got. And I thought I'd make it with a full capabilities. I can log in, authentication, and the whole lot. So I've got an Azure service, and this actually uses the mobile service client so that I can call Azure functions. I can authenticate using Facebook authentication. I'm using things like secure storage to actually save down the value of the authentication details. So it all comes from Xamarin Essentials. So I've got this whole service here that reads the balance from Azure function, can write the balance back to the Azure function if it needs to, if I want to do an update, if I want to give us some more money. And then this whole app, so I've got my model, which has got the balance, the currency symbol, and then what mode the UI is in for doing different things. I've got a copy of my service, the model, which I'm ignoring when I serialize it. And then in my init, I spin up a new model here with a 0 balance. And then I have this command of async message. So I create this async method that actually goes and loads the latest balance from my Azure function. So it makes an API call and then returns that model if we logged in. And obviously my update can handle changes to the UI and what have you. And then in my actual view function, where we're down here, if we logged in, and this is an asynchronous call here, if we are logged in, we return the main page. If we're not logged in, we return a login page. So this is kind of like my way of handling the modal stack. So the login page here is a XAML content page with a grid, with some rows, star, auto, auto, star, and 2 children, a button that says login with Facebook and a button that says login with Twitter. And then these functions will actually call a login function. And that login function, where is it? Somewhere up here. The login function will asynchronously call login on my Azure service, and then it'll dispatch a message to say I've logged in. So it handles that whole kind of call to my Azure service, which calls the mobile client, which is an object. So it's calling, so in login, I will actually make a call to log in this method here. This will actually go and have we logged in already? If so, load it from secure storage. If not, then actually make the call itself. So yeah, so you can very easily interact with different objects from your Elmish code, just by the idea of the fact that when you do something, a message gets dispatched, and that helps synchronize everything up. And I will just add as well with this is one thing that gets quite confusing with MVVM and C# is things like dependency injection. It's how do you manage all the different things that come together? Now in F#, being a functional programming language, you don't really think about I have to implement an interface and I have to pass that interface into my object. So don't inject as such. You instead do kind of what I like to think of as function injection. So when you use the mobile service client with Azure, you actually have to have some platform-specific code written. I have to have a function on Android that uses the current activity to spin up the web view to log in. On iOS, I need to have the current view controller to log in. Now, normally you would create a class that implements an interface and then use something like the dependency service to provide you that platform-specific implementation. But because I'm doing functional programming, I don't have to do that. I have an auth function, which takes a mobile service client and the provider and returns the user. So it returns whether we successfully log in or not. And then, yep, so mobile service client, authentication provider goes to bool. This is an async method, an async function. And then when I construct my app class, I pass that function in. So instead of having some kind of IOC container that I resolve an interface, I just pass in a function. And then that function comes in here, gets passed to my Azure service. My Azure service gets passed to my init method and then gets held by my model. So you don't have to do dependency injection with objects. You can just do it simply with functions. So yeah, you can build these much more advanced capabilities all in F#. You can interact with other classes, Xamarin Essentials, internet calls, whatever, all in F#. Cool. So let's kind of just wrap this up in the last kind of 8 minutes or so. So where are we with the framework? So this, I will say, this is something that's new. So this is still very much under development. But this isn't something that it's just somebody's weekend project. This is a thing, we are building this, we're building it very much out in the open to help build Xamarin apps with F#. This is Don Syme's day job, essentially. I'm sure he'll hate me for saying this, but essentially this is part of his day job, is to build this framework. So it's getting a lot of support from people to get this done. The framework's pretty stable, it works well, we're constantly fixing and improving things as we go along. So, you know, it will keep getting better and better. One problem we have with full Elmish is we have this virtual user interface. Now, it works really well for Xamarin.Forms controls because we've built the virtual versions of those. If you want to bring in third-party controls, at the moment you have to write a little bit of code. It's about 50 lines of code to allow you to use a third-party control with full Elmish with a virtual UI. But we are working to improve that. We're probably going to drop in a type provider so that you don't need to write any code at all. But that's going to come over time. We also got the point where the namespaces might change. So that XAML.content page, XAML.navigation page, what have you, that's probably going to change to be something that's not XAML, because obviously, you know, it's not XAML. And obviously we're doing a lot more work on things like navigation, helping to make that better. We've got some great docs, but we're working on improving those docs. There's been building more samples. So there's a lot more work being done. And obviously it's open source. So if people love this and they want to get involved and they want to help build it, they can get involved in doing this. But what's there now is certainly usable to build apps, in production quality apps. Even though it's the NuGet still in preview, I would feel comfortable using it for some quite simple apps to get started with. And as I said, this is something we are building as the way to build F# apps with Xamarin. So you kind of see this as like a sneak preview of what we're actually going to be doing in the long run. So let me just zip over to PowerPoint. Always makes me lose my mouse. Here we go. So everything's on GitHub. It's part of the FS projects repo, which is the official F# projects repo. So if you want, this isn't something that's just in someone's personal project. It is part of the FS projects repo. So it's definitely very much a thing. We've got some great documentation that we're constantly working on to improve it. It's all available as FS projects / Elmish.XamarinForms on GitHub. And I've started building an awesome .Elmish.XamarinForms list of cool stuff with some demos, documentation, videos, blog posts, etc. So if you ever play with it, raise a pull request here to put your samples on there, put your examples, anything cool you've built. So you want to get started? Yep, it's all on GitHub. Now, we have got a .NET new template. So this is all detailed in the documents. So you can actually do .NET new -i Elmish.XamarinForms to install the template, and then .NET new Elmish.XamarinForms to spin up a new Elmish application. We are actively working to bring that to an extension for Visual Studio on Windows and Mac, so you can go File, New, and get a new project created. We're hoping to get that done. Well, I'm hoping to get that wrapped up this week, but we'll see how much time I get. But yes, so we are going to try and build that experience in, and then the aim will be eventually to have this kind of built into the product. So when you install the Xamarin workload in Visual Studio, one of the options under Visual F# will be Elmish.XamarinForms app, and it'll just be there as part of the product. So again, it's not just someone's play project. This is something that will be part of the product. We've got some samples there. I've got like a tic-tac-toe example if you want to play noughts and crosses. Don's got his own version, the same thing, written in a much more concise, more F-sharpy style. My little piggy bank app is there. We've got a few other examples. We've got an implementation of the iOS calculator app in like 100 and something lines of code that shows just how good it is. So we've got lots of great samples around. And if you want to get started, I'm happy to help out. Don's fairly happy to help out. So get in touch. Ping us on Twitter, ping us on email, and we can work with you to get your first apps built. And obviously, we'd love to see all the kind of cool stuff that you're building. So yes, here's some actual links. So these are the things to actually follow. If you want to read more about F# and Xamarin in general, then we've got that on our docs at academy.ms/XamarinFSharp. Then for the actual Elmish stuff, github.com/fsproject/ElmishXamarinForms, and there's the link to the awesome one. And ping me, let me know what you think about it. Let me know what kind of apps you're building. I'm on Twitter, email, all my details are there. And yeah, I think we're pretty much at the hour. So Rob, any more questions to round off with?
Yeah, two more here. So at the beginning, you were talking about how you don't have to declare your variable types and things like that. So if you have your own types that are custom types, does the compiler still work that out?
Yep, it does.
Yep. Yeah.
So I'm just trying to think. Well, let me just flip to a window where we can see that. Yeah. So if you look at this update function here, this takes a message and a model and returns a model. And nowhere here have I actually said that this is a model, this is a message. Instead, it knows from the implementation of the app here, it knows that program.makeSimple is expecting an update that takes a message and a model. So, because it knows that the return type within it is this model type, and it knows that it just knows what's expected. So just by building this up, passing these types in, the compiler can work out what these types are. Again, here we match the message with increment. The only type that could match with increment is this. So therefore, this has to be one of these. Right. The only type that matches here, that this could be is a model. So yeah, the compiler's really, really smart. Sometimes it doesn't get it right, so you do have to tell it. You have to explicitly say that, you know, this is main page.model. You know, sometimes you have to tell this, but most of the time, the compiler gets it right.
All right, and then we got one more question. What about interacting with currently available NuGet packages that are written in C#? Can you use them directly together with F#?
Yes, you can. So, for example, in my piggy bank app, I'm actually using Microsoft Azure Mobile Client. And that's C# bindings around an underlying Objective-C library to interact with Azure. Newtonsoft.json. So, Xamarin Essentials, all written in C#. Xamarin.Forms is written in C#. So, yes, F#, although F# is a functional programming language, it's only functional first, which means it's fully object-oriented. It can access anything in the .NET framework. This core library here is a .NET standard library. So this can interact with any other .NET standard library exactly the same as C#. So you've got full interoperability. That's kind of why Microsoft is overseeing the development of F# and still retains the final level of control, because they want to make sure that this stuff works. This stuff is not broken.
Under the covers is all still .NET, right?
It's all still .NET. This, if you compile this down, you get IL out the other side.
Right.
So yeah.
All right. So I think that's all the questions we have. Thank you so much, Jim. And like Jim said, if anybody has any questions, feel free to reach out. We will have this video up on our site in the next couple of days. I know there's a lot to go over. I definitely suggest watching it again if you need a refresher on any of this. Go check out his links there. Get started with F#, get started with Xamarin.Forms. And that's it. So keep an eye out for more Xamarin University guest lectures. We have one coming up on reactive UI. And if anybody would like to host a guest lecture for us, just reach out to me, Rob Gibbons, and let me know. Would be happy to hear it. So thank you, Jim. Thank you, everyone. And we will see you next time.
Thank you.